Hello, welcome to the course Mathematical Foundations of AI and DS. I am Dr. Vinay Raj from NIT Tiruchirappalli. We know that mathematics is very essential for any basic concepts of computer science. In same way, mathematics is also very important for AI and DS. Concepts like vectors, matrices, linear algebra, probability, statistics, distributions, etc. so on will occur a lot in machine learning and data science. So, in this course we are going to study lot of concepts which can help us understand why and how the machine learning algorithms work. So, let us dwell into the course and understand the concepts of which are mathematical concepts which are required for AI and DS. Before we go into understanding lot of mathematics, let us see the relation between AI, machine learning, deep learning and data science. These terms are frequently used, though we say it is mathematics for AI and DS, but overall if you observe the concepts in artificial intelligence include machine learning, deep learning and data science. So, we will see all the mathematics required to understand all the concepts of machine learning, deep learning and data science. What is the relation? Why we have to study mathematics for machine learning? So, let us see the definitions of machine learning model. If you observe one of the definitions of machine learning, it says that machine learning model is a type of mathematical model, meaning the model whatever we are trying to build is a mathematical model. So, obviously there is a requirement to understand the mathematics behind the AI and DS. So, it is a mathematical model after being trained on a given data set can be used to make predictions or classifications. This is one definition where it quotes that it is a mathematical model. The other definitions if you see, mathematics is the heart of machine learning. So, it is very clear from this that no mathematics is essential to understand machine learning. I would say that machine learning is not new, it is all just a programming or a computer science attached to the mathematical concepts which has brought this new term AI or machine learning. Machine learning is also mathematics. One of the definitions from different textbooks, it says that machine learning is mathematics. So, this creates an awareness that we have to study mathematics for machine learning concepts. So, overall in this course we are going to study about different concepts which are explained here. If you see, the four pillars of machine learning are regression, dimensionality reduction, density estimation and classification. So, these are the more four important concepts what we have in machine learning. And if you see the foundational mathematics, we have vector calculus, linear algebra, probability and distributions, analytical geometry, optimization and matrix decompositions. So, this is the core machine learning and its foundational mathematics which is required for us to understand machine learning and data science algorithms. So, in our course, in this first course, we are going to study about linear algebra, matrix decompositions, vector calculus, probability and distributions, optimizations, statistics, regression analysis and some metrics which are frequently used in machine learning and data science. So, the how and where this mathematics is used, why we have to study this mathematics and how the mathematical concepts are going to help us in this course of AI and DS. Generally, mathematical data or the machine learning data is always in the form of numerical form, and we represent that numerical form as vectors. Table of such vectors is forms a matrix. So, when you have a machine learning data with you, it is mostly converted into numerical form, and that numerical form we represent them as vectors. So, when we talk about matrices, we have to study about linear algebra, because the study of vectors and matrices is called linear algebra. Now, given two vectors representing two objects in real world. So, we understood that from the first point that ML data can be converted to numerical form, and the numerical data we represent as vector, and table of such vectors is a matrix. So, when you have two vectors with us which are representing real world objects, then we want to make some comment about their similarity. Why I have to make the comment of similarity? Because the idea is that vectors that are similar should be predicted to have similar outputs by ML algorithms. So, if there are two vectors V1 and V2, if I give vector V1 to an ML algorithm and it is giving me an output as O1, then it is when V1 and V2 are similar, then it is obvious that even the same ML algorithm should give an output similar to O1. So, I mean to say the output O2 should be similar to O1. So, when we talk about similarities of vectors, the construction of similarity and distances is related to analytical geometry. So, this is clear that why we have to study the concept of analytical geometry to understand the concepts of AI and DS. Sometimes the data size is large. We cannot always expect a small data into a 3 by 3 matrix or maybe some 10 by 10 matrix. We have a huge dimension data with us, and when the dimension is very high, the data size is very high, obviously the matrix size is also very high. So, in such case what we do, whatever matrix operations we have, we cannot apply those operations on such large data. So, there creates a necessity to decompose or to reduce the size of that higher dimension matrix into smaller dimension using the concept of matrix decompositions. Then we often have noisy data in the machine learning data. We cannot always expect to have 100% accurate data. Why? Data is collected from different sources and there could be some noise, there could be some bugs in the system, or there could be some flaw or some issue in the system which all generates some noisy data in the data set. When we have a data set which is noisy observations with noisy observations, therefore, the models which are built on such noisy data will have definitely some uncertainty. I mean to say here that suppose the data set what we have with us contains some missing values or some junk values in the data set. Then when you are trying to build a model on such junk data or on such noisy data, it is obvious that the model which you are building will not be 100% accurate. So, there will be some uncertainty in the sense it could be 95% accurate model or it could be 70% accurate model. So, there is some uncertainty, we cannot say how the model will predict or how the model will perform. So, there is a chance of uncertainty. So, when we talk about uncertainty, the quantification of uncertainty is the probability theory. Therefore, we have to study probability theory because we have lot of machine learning algorithms which are based on this probability theory. Now, when in the first slide I have said that machine learning models are mathematical models. So, when they are mathematical models, obviously we have lot of parameters which we have to either maximize or minimize to improve the performance of the models. In such case, we have to use the concept of gradient. Why? Gradient means we find out the derivative or the partial derivatives of a mathematical equation which can optimize the ultimate model. So, we have to, when we talk about gradient, we have to study the concept of vector calculus, so on. So, next when we talk about we said that we have mathematical functions and we have to maximize or minimize the parameters which are available in the particular mathematical function. So, we talk about optimization here. Again statistics. So, if you have seen till now I have been talking about data. So, so there is lot of study required to understand the data, how is the data distributed or how is the data, what is the frequency of each class of the data. So, we have to use lot of statistical tools and techniques because statistics gives us lot of techniques with which we can derive meaningful insights from that, which data scientists generally use to make some business decisions. So, when we talk about data science, statistics is one of the very important concepts which is useful in data science. So, this is one simple diagram which clearly shows us that what level of each of these concepts are required. If you see, it is very clear that the algorithm part is just 15%, rest all focuses on the mathematical concepts. So, if you want to understand machine learning, you have, it is obvious that we have to study machine learning mathematical foundations. Once you study this course, after completing this course of mathematical foundations of AI and DS, you not even understand the existing ML algorithms, but it also creates or motivates you to define or create your own or propose your own machine learning and deep learning algorithms. So, with this I end my first session. If you have any queries, please write it to me. Thank you.